Hi, welcome back. So for part 2, we're going to take a look at just a few more examples. Remember, we've been looking at where a function is increasing and decreasing, where we have relative max and mins, as you kind of see right here. So for number 5 and number 6, we're going to take a look at just a couple more examples here. They won't take us very long. So remember, we are looking for our critical numbers. And for a question like number 5, my recommendation is always write this as a single fraction if you can. And I'm going to go ahead and take care of that right now. My common denominator is x, and that's just going to give me x squared minus 1. And I'm going to take the derivative like this versus in this form right here. So when I take the derivative, I'm going to get low, use my quotient rule, low, d high, minus high, d low, which is just 1, all over the bottom squared. And if I simplify that, we would get 2x squared minus x squared, so we would get x squared plus 1 divided by x squared. And there is our derivative. Looking for the critical numbers, we want to find out where the derivative is 0 and where the derivative does not exist. So to find out where this function is 0, that's easy. We learned that. That's just where we're equal to the top. We just look at the top of our function right there. And setting the top equal to 0, we get x squared plus 1 equals 0. And the bottom, we get, so if we try solving it, we get x squared equals negative 1. Which, of course, we can't do right there. So we don't have to worry about that. There's no place where this will have a horizontal tangent. Looking at where the slope does not exist, we do have one. If we set the bottom equal to 0, remember Leibniz says just look at the bottom, we would get just x equals 0. Now be careful, this is a vertical asymptote. That might come into play later on, okay? So we want to identify that as a vertical asymptote. And we know that from the beginning. Doing your sign chart, let's go and do our sign chart. We only have the one critical number at 0, your derivative and your function on bottom. And I'm going to pick a number less than 0, negative 1. When you pick a number less than 0, remember we're going to plug these into the derivative. And I like to write out what the derivative is here. On top, because I'm squaring it, the top is always positive. The bottom's always positive, so that's positive. So the function's going up. Plugging a number bigger than 0, like 1, we would get positive over positive again, which is positive, so again it's just going up right there, so pretty easy to do. So we would then say this function is increasing on the domain. Now be careful, this is a vertical asymptote, so I should identify that. It stops there. So we can go from negative infinity to 0, or from 0 to infinity. This is decreasing? Never. It's never decreasing. There's nowhere the slope is negative. If it were decreasing, we would see that in our sign chart. Do we have a relative maximum? And the answer is no. We don't have any because their slope never goes positive to negative. Do we have a relative minimum? Again, the answer is no or none. And that's because the slope never goes from negative to positive. And there's our answers right there. Very easy to do. My only suggestion is, like I said, we want to write these as a single fraction. That helps out tremendously for us. All right, for question number 6, okay, that should be a 2/3, I believe. Hold on here, kind of hard to see. Yep, that should be a 2/3. So again, I'm going to look for my critical numbers. Taking the derivative, f prime of x would become 2/3 x squared minus 4 to the negative 1/3. Be careful, chain rule times 2x. Write this, get rid of that negative exponent. We would get 4x over 3 times x squared minus 4 to the 1/3. Now be very careful, okay? A lot of times people think there's going to be a vertical asymptote. There aren't any here. Vertical asymptotes come from the original function. So when you're looking for your critical numbers, where does the derivative equal 0? And where does that derivative not exist? Of course, we set the top equal to 0, we get x equals 0. The bottom, we're just really looking at that x squared minus 4, because everything else just goes away. we get plus or minus 2. Note, these are not vertical asymptotes. That would come from the beginning. You can have 0 in this fraction here. You just can't have 0 in here. So this probably tells me that this is probably a cusp, most likely. It's not differentiable at plus or minus 2, so it's probably a cusp. Not differentiable because the derivative does not exist there. So when I do my sign charts, 0, negative 2 and 2, my derivative, how does it make my function look? Plug in a number less than negative 2, like negative 3, plugging it into the derivative. Ready? That's this 4x over 3 times x squared minus 4 to the 1/3. If I plug in like negative 3, the top is negative. Let's do the bottom. Be very careful. Don't worry about the 3 really, right? So I would get 9 minus 4, which is positive. So this is negative, going down. Pick something at negative 2, and that, like negative 1, the top again is negative. The bottom, this is really saying 1 minus 4, which is negative. I can take the third root of a negative, so that's negative. So we get positive here. Whoops, sorry, that's going up. I could just go down. Plug in 1, and I get a positive on top. And on the bottom, what do we get? A negative. So this is negative. This is going down. Plug in something like 3, positive, and the bottom is positive. So we get a positive right there. Whoops, sorry, it's going up. There, I could just go down. So where is this function increasing? Well, it's increasing on negative 2 to 0 or 2 to infinity because the derivative is positive. Oh no, I forgot to put that over here. Because the derivative is positive. I forgot to put down my answer. Look at you guys, I'm like a student now. I remember now, but it's just cram it in. It's decreasing between negative infinity to negative 2 or 0 to 2 because the derivative is less than 0. And we do have a relative maximum at 0, x equals 0, and that is because the derivative goes from positive to negative, and we have a relative minimum at, we actually have 2 of them this time, at plus or minus 2. The slopes go from negative to positive at x equals plus or minus 2, and that is because the derivative goes from negative to positive. And if you want to see what this looks like, this graph kind of goes down, up, down, and up. That's what this graph kind of looks like right here. And if you notice, this is the world famous Warnow function. Hope you enjoyed the video. I will see you guys later. Thank you. Bye-bye.